This is section 12.5. This is the first day of working with chapter 12. A few things that we need to talk about if we're going to start with the fifth section, but have it for our first day. We need to know what a sequence is. A sequence is a list of numbers that we'll typically write a rule for. It's just a list of numbers. Then there's another term we're going to learn about called series. A series is also a list of numbers. It usually has pluses in between each of the numbers, but it's a list of numbers we find a sum for. So a sequence is just simply a list of numbers. We usually put commas in between them. A series is a list of numbers that we put pluses in between, and we'll find the total sum of that series. Right now we're working with a sequence. We have an explicit rule. There are explicit rules and recursive rules. They're written differently. Today, a lot of our lessons are going to be working with recursive. The recursive rule gives initial terms or a sequence, and then a recursive equation tells how the term is related to the previous one. Okay, that's one vocabulary. We're going to look for an initial term, and then we're going to give the rule of how the future terms are related to the previous term. There's something at the very end of our lesson that's called iteration, and that's the repeated composition of a function with itself. You figure out the value of, say, f of 2, and then you figure out its answer, then you plug that back into the equation and get its answer and plug that back into the equation. You repeat it. Then there's an explicit formula, which you would have learned previous to this 12.5. We won't need it necessarily much today, but it gives a term. A of n is just a term. It's like the 10th term or the 5th term, whatever you want a of n to represent. It gives it in terms of the position. Position number, and we often represent that as the letter n. So if you wanted to know what the third term was in a list of numbers, you should type in a 3. If you want to know what the 10th term is in a list of numbers, you would type in a 10. Recursive, if you want to know what the third term is, you first have to start with the first and calculate the second and get to the third. If you want to know the 10th, you have to start with the first and work your way all the way up to figure out what the 10th term is. Let's try that. We're going to find we're going to write a sequence given this recursive model. A of 0, most of the time we're going to call it A of 1, but here they like to represent it as A of 0. Your very first, before anything's done to it, the number is 2. Then you're going to take this number. This says A of n. That's your next term. We'll often call it A of 1, and then we'll try to find out what A of 1 is. And then we'll call it A of 2, and we just keep working up until we get to our last term, typically called A of n. This is A of n minus 1. This whole piece is your term minus the 1 before it. So it's A of 1. It's actually A of 1 minus 1, which is A of 0, which is back to this guy. And then you subtract 3 from that guy. Let's try it. So to find A of 1, we're going to take the previous term, which is A of 0, and subtract 3 from it. So the previous term is 2. We'll subtract 3. We get -1. To find the second term, we're going to take the previous term, called n minus 1. You subtract 1 from this guy. So our previous term was -1, and subtract 3 from it. To find a of 3, we're going to take the previous term and subtract 3 from it. To find your fourth term, you're going to take the previous term, which we like to represent as a of n minus 1, means the previous term, and subtract 3 from it. So our previous term, the a of 3, that was -7. A of 5, we look at the previous term, a of 10, or which was -10, sorry, and subtract 3 from it. So here is a list of numbers. It's called a sequence. We're not doing anything with those numbers at this point. We just have a list of numbers called a sequence. We'll try it again. We'll find the first several terms of our sequence. We're going to start out with our first term, our a of 0. That's clearly 4. Now what this rule says is to find a term, you're going to take 1.5 times the previous term. So to find a of 1, we're going to take 1.5 times the previous term, and that comes out to be 6. To find a of 2, we're going to take 1.5 of the previous term. A of n minus 1 is your previous term. To find the third term, we take 1.5 times 9, which gives us 13.5. Gets a little more complicated when we take 1.5 of 13.5, we get 20.25. And then to find a fifth term, that would come out to be 20.375. So we were multiplying 1.5 times the previous term. You can illustrate this with a calculator. If we start out with the original number, which was 4, we're going to say 1.5 times the previous answer, previous term. And we got our 6, we got our 9, 13.5, 20.25, and 30.375. Your calculator does this recursive rule automatically. So if you relate it to that, you might understand it pretty well. Doing the calculator rule for the first example, you would start out with 2 as your number. Then you would take your answer and subtract 3 from it, and that's where we come up with -1 and -4, -7. And you can represent that forever. Recursive equations for arithmetic and geometric. First of all, you need to know what a arithmetic sequence is. It's a sequence, so it's a list of numbers. But we get this list of numbers, it's formed by adding. You could also subtract by adding a constant. A geometric sequence is a list formed by multiplying we're going to multiply by a constant. Arithmatic, that's how you pronounce it. Arithmatic is by adding or subtracting the same thing again and again. Geometric is by multiplying, or actually dividing, multiplying by the reciprocal again and again. Write the recursive rule. So here we look at this group. We can test to see if this is arithmetic. Are we adding the same amount every time? Sometimes you can look at it real closely and see that you are, but if you want to test it mathematically, you can take a term minus the term before it. That's what that a of n minus 1 was. So we're going to take a term which is 7, and we're going to subtract the 1 before it, and that was 6 apart from each other. Then we can take a term and subtract the 1 before it, and it's still 6. 19 minus the 7 is 6. 25 minus the 19 is 6. So we have a common difference that equals 6. So if we're going to write this rule, we first need to represent the first term, which is clearly in front of us. So our first term, we typically write a of 1. We don't write it as a of 0. We write it as a of 1, and that is 1. Then we have to write what the real pattern is. You're taking the 1 and you're adding 6. Then you're taking the 7 and you're adding 6. You're taking the previous term and you're adding 6 to it. Both parts make the recursive rule. Here, you might look at it and think, are we adding the same amount? This goes up by 8. This goes up by 24. It's not going up by the same amount every time. There is a test to see if it is geometric. We can test a term divided by the 1 before it. A of n minus 1. So if you take the 12 and divide it by the 1 before it, which is the 4, we're going to get 3. If you take 36 and you divide it by the 1 before it, which was the 12, you get that common multiple. It's called a ratio. If you take the 108 and you divide it by the number before it, we get the common value. So we have a common R, it's called ratio, of 3. So our first term is right in front of us. That's a of 1 that equals 4. And then the real rule, you need the 4 to know where to start. And then what are we going to do with the 4? What does it take to get to our next value? We noticed that we were multiplying 3 all the time. So we're going to take 3 times the previous term. We'll write the rule for this. The first thing you have to think about is, are we adding up the same value every time, or are we multiplying the same value every time? Here, we're definitely not adding the same amount. This is going up very quickly. So we must be multiplying. What are we multiplying by? Well, we can test it. We can take our term and divide it by the one before it. So take your 27 and divide it by the one before it, and it's 9. Take 243 and divide it by the one before it. Using a calculator, you'll see that it's 9. So that gives us evidence that our R value is in fact 9. So we start out with A of 1. You always got to write the first rule, or the first term. Got to tell us where the sequence is going to start. Because if you're going to multiply it by 9 every time, you'll have a different list of numbers if you start at 4 or if you start at 5. We're going to start at 3. We're going to find our future numbers by multiplying the 9 times the previous term. Here, we're definitely not adding the same number every time. So let's test and see if this is actually arithmetic. We're going to take our term and subtract our previous term from it. So if we take 78 and we minus 89 from it, we get negative 11. If you take your next term, which is 67, and subtract the previous one, which is 78, you'll get negative 11. Take the 56 and subtract the previous term from it, you'll get negative 11. So our common difference is going to be negative 11. So to write this rule, we always start with our first term. What's our first term? 89. Then to find the next term, all the next patterns, what pattern are we using? You're taking the term from the previous number and you're subtracting 11 from it. So you're taking A of n minus 1 and you're subtracting 11, because that was our common difference.